I just think they're a really good resource to use if you want to work ahead, or if we don't finish them all, I can ask you to try one at home. Like, they're really easy to just not look up at the board and just try a problem. So if you remember, the last thing we did was solving systems of equations using substitution. I personally think substitution is the harder of the two, but yeah, I got so sick of writing it that I was like, check the answers. So 7.2 is using elimination to solve these systems of equations. There are very different problems you're given in which you will use the two different kinds. You will always have a need for substitution. You'll always have a need for elimination. One will likely be the easier one to use. In our last day of this, we'll talk about what to use, when, and why before we move on to matrices. But I know. That's why I'm starting guided notes too. You will definitely want guided notes when you do matrices, because my God, you will get so sick of writing matrices out. They are. Matrices are a doozy. It's more just that you get sick of writing the exact same thing over and over and over again, because it gets super exhausting.
So basically math.
A little bit, yeah. All right, so this is the first problem. So in this one, I have two equations. I always label them 1 and 2, so I can talk to you about them, about numbers, and not say the whole thing out. So why I can use elimination with this one is because it's blaringly obviously set up, and they're not always going to be this way. They're likely not going to be this blaringly obvious. But when I'm looking at these two, I literally have the same positive and negative version of one term. So we set up addition, and we start our cancellation process. We add like terms straight down. It's like you're setting up a full-blown addition by hand. So add straight down, 3x and 3x cancel each other out. Oh wait, this is a, what's that?
But there's like 80 of these.
Yeah, the PSAT is loaded with these, with substitution and with the elimination. Sorry, I thought this should have been a positive. So 5y minus 2y is 3y. 7 minus 1, or 7 plus -1 is 6. So just like that, I'm down to a super simple one-step solvable equation to get y equals 2. Yes, and then I want to find my x value, which I can plug that into either 2 or 1. I'm going to plug it back into 1 because this one doesn't have any negatives. We prefer positives. So I take it back up into this first one and do 3x plus 5 times 2 equals 7. 3x plus 10 equals 7. Subtract 10. 3x equals -3. Good, to give me x equals -1. Write that as a coordinate pair. And this is the big part that the SAT will ask you to do. They generally never ask for just like an XY. They always say, give us the coordinate pair. And it would be -1, 2, because you write XY. Okay, simple enough.
Yep.
Not the hardest thing you've ever done, for sure. Okay, this is the easiest thing. You had to do no manipulating. It was set up for elimination before you even started it. So if you look at the second equation then, or second problem, is that one set up immediately to start elimination? No, not immediately. We can do a small manipulation to it. So think about, and you might not exactly know what I'm talking yet, but think in your head, looking at these two equations, is there something you can do to one or both of them that you will be set up for elimination? Does it have to be negative?
Multiply by the top and by 2.
Good. Positive.
Then the x is canceled.
Good. Okay. So Avery's up here saying, if you multiply some stuff by 2, then we can have some things cancel. So I want to first say why we even chose that. I have x terms and I have y terms. When I'm looking at x's, one's positive, one's negative. When I'm looking at y terms, both are positive. So the term that you use, whenever you cancel, one has to be negative, one has to be positive, right? Same value, they cancel that way. If I already have a positive and a negative, I'm gonna utilize that. It makes my life easier, just because I don't have to multiply that negative in that. So in my case, and there's so many ways you can do this. You could do it to cancel out your y's instead to make them both 5y, negative 5y. I am going to focus in on my x's, and I want to make these both 8x's, one positive, one negative. To do that, I'm going to multiply my equation 1 by 2. So everything in that gets multiplied by 2. I got my new equation 1, that is negative 8x plus 2y equals 18. Now I'm set up for elimination. I can throw my addition sign in and start canceling. 8x negative 8x cancels. 5y, 2y equals 7y. Negative 11 plus 18 is 7. And this is where you slowing yourself down and making sure you're adding and subtracting and multiplying right will be huge, especially once we get into a 5 by 5 matrix. If you add or subtract or multiply one thing incorrectly, you are screwed. You just spent 50 minutes on a problem that means nothing anymore.
You said 15 or 50?
Well, depending on how long they are, it could take 50. We'll do ones that take more like 50, a problem. But you will be screwed the entire time if you cannot add, subtract, and it's going to be fractions, decimals, negatives, positives. You can't do that. You're screwed. Yes.
I can't.
I'm like just like actually genuinely like
Curious.
I understand people that aren't impressed with math.
Why?
Like, you're not a genius. You're not like you're not a genius. Like, you don't remember everything. Like, how could you just remember doing it? I could never. If I can't think of something to memorize from one chapter, from one week to the next quiz, I don't know how you could like think about this and remember it and keep it.
Yeah.
Like it's like
I will say I have so much math going on in my head.
I really
So
I would-
many
I would go to
formulas.
sleep every day, every single thing.
I could not. I could not do that.
I do dream about math sometimes. I'm ashamed to admit it, but I do. Shows up in my lifetime. Thank you, Isaac.
I would
Thank
cry.
you.
I know that.
I think you're the
I'm
best.
saying, like, I'm like all math teachers in general. Like Mr. Davidson.
Mr. Davidson,
Yeah.
crazy.
Come on.
Whip
He
that
could just-
stuff
he could-
out.
He could just pull it right from the back of his
Inventing
head.
like freaking chemistry stuff. Like you're not like.
I know, my intelligence is limited. I'm kidding. I'm kidding.
You're not like.
Right. No, I know what you mean. Yeah. I know what you mean.
I could never ever do it.
Thank you, Isaac. I appreciate it. There's a lot up there.
There's a lot.
All right. So one step equation solve. Y equals 1. Easy peasy. So now I have 3 different equations I can plug this back into. You can always use the new equations you created. It's fine. You can. Do I want to? It's bigger numbers. Not necessarily. It's kind of the stupider thing to do. Stupider. Well, now I really just tested my intelligence. Okay. I would go back to the lowest numbers, maybe no negatives in it, anything like that. But you can use any 3 of these. You will still get the correct answer because this is an equivalent equation to this equation. For the sake of the fact that that's where my space is at, I'm going to go back up to the first one. So this would be negative 4x plus 1 equals 9. Subtract 1 to get negative 4x equals 8. Divide by 4, negative 4, x equals negative 2. So this coordinate pair would be negative 2, 1. All right. Still not that bad, right? Like not the worst thing ever.
Sure.
I want you to try number 3 by yourself. So keep in mind, I said you can multiply 1 or 2 or both of them by something. So both is always still an option. You will at times have to multiply both of them by different numbers to get to a common term that can be canceled. And again, you might have a different idea than somebody else. As long as you're doing it mathematically correct, it's fine. There are many different ways to solve these and make them set up for elimination. Some are just easier and quicker than others. Oh, no, did I open up the? No. this is right. Okay, and I'm only gonna give you a couple minutes to try this, because if you're kind of not understanding, it will, yeah, I don't wanna send you off for too long. Okay, if you think you have the hang of it, keep working on it. And you can kind of tune me out. And again, if you tried something that I did not, keep doing what you're doing. You are likely doing it correct. It's fine. I'm not gonna say you have to do it my way. So the way that I'm looking at this is I have two positive X terms, but I have a positive and a negative Y term. That's like, for me, I love that. I'm gonna use that. If I were to use my X terms, I would just have to ensure that when I did this multiplication, because my common term here would be 10, that I multiplied one of these by a negative value, and then the other one by a positive, okay? Because I have to introduce that negative. I'm not gonna do that because I just don't feel like it. I have a term that allows me to not have to introduce a negative. The more negatives you bring in, the more room for error it creates. I'm gonna stick with the positive version, which is dealing with these Y values. Okay, that just was another option. I'm going to use my Y's. 12 is gonna be the lowest number I can get to with them. So in order to get to 12, 3 has to be multiplied by 4, 4 has to be multiplied by 3.
Wait, what?
I want to get to 12. So 3
Oh, so
times
you
12,
didn't,
good.
oh, you didn't.
But yeah, I didn't use the X one. You can, but I
Yeah,
didn't
I
because
did,
this is
yeah.
easier. So if I multiply this through, I get 20x plus 12y equals 36. And where am I at? 6x minus 12y equals 42. Good. Okay, I was like, in my head, it almost looked like 48. All right, so this is my new equation 1, my new equation 2. I'm now at the point that I can cancel. So I will say, yay, 26x equals 78. Divided by 26, x equals 3. Okay, so don't be afraid of large numbers when you're dealing with this
Oh,
multiplication.
you're using X, duh.
Yes, yeah. Okay, so when I'm dealing with some of these, like you're multiplying a 14 by 3, like you're gonna get to some larger numbers. Go ahead, and now you have 4 options. I can plug this x back into these new ones or my old ones. I always like to go back and use old ones because they're much smaller numbers. So I get 5 times 3 plus 3y equals 9. 15 plus 3y equals 9. Subtract that 15, 3y equals -6. So y equals -2.
Got it.
So we get 3, -2. No matter what way you did it, you got 3, -2 as your final answer. Okay, so think back to last week when we did substitution. You could check yourself algebraically, correct? I could plug 3, -2 for my x and my y, and I should simplify that out and get 9 equals 9, right? I can solve this graphically by plugging this into my calculator, checking for their intersection, right? That's another way you can do these. All just as simple, okay? We have 2 final last ones. They're super quick, super easy. I just want to help you with the explanation of them. So if you're already going through them, keep going through them. You're doing great. These last 2 are special cases. So we had the special case of no solution, and we had the special case of infinitely many solutions.
Whoa. The X and Y cancel out.
It's the same for number 5, the X and the Y will cancel out. Like everything cancels out for number 5.
Yeah.
That's so weird.
All right. So with this no solution one, I would solve it like normal, right? Like this is just a special case that I want to make sure you know can happen. My choice would be to multiply my top equation by 2, because that's going to get me to a nice, simple 2x minus 4y equals 6, okay? I'm at the point that I know my x's are canceling, so I can set this up for elimination, only everything starts getting, yeah, meeting, yeah, go ahead. So x's cancel,
4.
y's cancel,
and
which
you're
means
left
I have
with 6.
0 on this side equals 1 plus 6, which is 7.
Wait, what?
If I was a mathematician, not,
Yeah,
I would want to put a hammer to my head because if I ever got a problem with that, I have no solution. Like
Yeah,
you were like,
it is,
you're
yeah.
a mathematician, like you were
right, you did the whole thing, then you get down here like, are you kidding me?
I mean, like,
So can
Don't stare at it.
0 equal 7?
yeah.
No, 0 does not equal 7. So since they're not equal, yes, it's no solution. Well, let's talk about this. That doesn't say solution. That was horribly written. Let's talk about this graphically. If you were to solve these out for y, you would get the exact same slope of 2x and 2x. If something has the same slope but different y-intercepts, what kind of lines are they? Parallel. Do parallel lines ever cross?
No.
Okay, so we have solutions at intersections. No intersection, no solution. Next problem. 2x minus y equals 1. 4x minus
This one,
2y
everything cancels out.
equals 2. Oh. What did you multiply by?
-2.
Okay,
on
good.
top of-
So you had to introduce the negative, no matter what scenario you chose, you had to introduce the negative.
Yeah.
We have positives, negatives, negatives. So, here we go, I do it wrong. So my new two solutions, negative 4x minus plus 2y equals negative 2. So I know I'm set up for cancellation, so I can go ahead and do so, except everything cancels to get 0 equals 0, okay? If you chose to graph these, when you set them up to be y equals, you would have the exact same equation. Meaning, if I graphed equation 1, it would look like this. And then if I graphed equation 2, it would look like this,
Whoa.
okay? We have solutions at intersections, correct?
Yeah.
Where are these
Oh,
intersecting?
wait, everywhere.
Every single point. We're talking about the decimal versions of every single point you could ever think of, meaning right here, right there, right there, right there, right there, right there. The entire line is an intersection. So definitely many. Woo!
You're-
You know what?